This is video 2 for the classical mechanics. So in this one we're going to talk about rotational motion. So rotational motion is whenever we have something spinning around an axle or an axis. So think of a wheel. So in linear motion we use things like inches and feet and meters, something that we can use to measure position and distances and displacements. For rotational motion we need to use angles, and we're measuring the angles in terms of a unit called the radian. So let's say we have something that's spinning, and we have an object that's going from this position and it's stopping at that position. Well, since it's spinning, its radius is going to be the same, but it's sweeping through an angle. And what we can say is that this angle will equal S over R. Now, R is clearly the radius, so you may be wondering, what is S? S is something called the arc length. So if you think about it, an arc is like a curved path, and a length is like a unit of distance. So we get our arc length. Now for units, let's say S is measured in meters and R is measured in meters. Well, then theta will be unitless. Let's say S is inches and R is inches. Theta will be unitless because the inches would cancel out. Whatever your unit of R is, your unit of S will be the same unit. Those have to agree. So since they're unitless, we have to give them something. Well, we call them a radian. So what this is, this formula, is the definition for a radian. One of the common tools we have then is something called a unit circle. And this helps us to get an idea for different radians. So for instance, if something starts at this point right here and stops at that point, so it goes through an angle here. Looking at that, you can see that the angle is 60 degrees. But it's also pi over 3 radians. We use a rad for radian. So there's a similarity between degrees and radians, and we want to kind of go through them. We want to be able to kind of understand what is the relationship between a degree and a radian. And if we look at this graph or this chart, we see something kind of important right here. We see that 180 degrees is the same thing as pi radians. So if I know the degree, and I take the degree and multiply it by pi over 180, that will give me the radian. So let's take a look at this. If I put 60 in for the degrees, I have 60 times pi over 180. Well, 60 times pi over 180 would be 60 pi over 180. 180 divided by 60 equals 3, so we get pi over 3, which is what we see right here. So you can go through and you can put in any degree that you want to, just to use this little chart to check to see if it works. Now this is backwards compatible, so if I take the radian and multiply it by 180, not 18, 180 over pi, that will give me the degree. So for instance, if I were to plug in, let's say, pi over 2, so pi over 2 times 180 over pi, well, the pi's would cancel and I'd be left with 180 divided by 2, which is 90. So we see that pi over 2 is the same thing as 90. So these are just quick little ways of converting either your degrees into radians or your radians into degrees. Okay, other than that, the mathematics is identical. So here you'll see the three equations for linear motion. And they're the same thing as the three equations for rotational motion. So here, x is a position. Over here, theta is an angular position. Over here, we see that v is for a velocity, how fast something's moving. Over here, we have this weird looking w, which is omega, and that is angular. We go angular speed. I should call it an angular velocity, but I'll go with angular speed. So omega then is how quickly something's rotating. Angular speed, we can either measure it in radians per second or revolutions per minute. Those are the two most common. And we can take a look at how to convert between the two later. Over here on the linear side, A is for acceleration, which is when the velocity changes. So either speeding up or slowing down. And then over here we have alpha, which is the angular acceleration. So something's rotating, but then it slows down and it rotates slower and slower, or it starts rotating faster and faster. Its angular speed is changing. Its radians per second is changing for every second. Now we do have a bridge between the linear and the rotational. So they're pretty simple. If I take the speed, or the linear speed, that would equal the radius times the angular speed. I also have this relationship here that says linear acceleration equals radius times angular acceleration. And if we think about it, going back to the definition for a radian, the linear distance, or the arc length, equals a radius times that. So really, I could easily swap out that s for an x for a linear, like a linear type speed or distance. All right, we've got a couple minutes left on this video, so let's take a second and let's work out how to convert between radians per second and revolutions per minute. So let's say I have something that is, let's say 10 revolutions per minute, and I want to convert that into radians per second. I would use something called the factor label method. So I would begin by writing out my 10 revolutions per minute like this. So for every 10 revolutions I have, it's 10 revolutions per 1 minute. Now I start thinking, okay, if I have 1 minute, or I want to convert my minutes into seconds. I think, okay, well, there's 60 seconds for every 1 minute. And then I want to convert my revolutions into radians. And if I think about my unit circle up here, notice that if I make it one time around this circle, so if I start here and come all the way back around to my same point, I go through an angle of 360 degrees, or 2 pi radians. So in other words, one revolution is equal to 2 pi radians. I treat this like one giant fraction. So since this is one giant fraction, notice then that the minutes cancel, the revolutions cancel, and I'm left with radians divided by seconds. So I just go through and I multiply. So I got 10 times 1 times 2 pi radians. So that's 20 pi radians. And then I just multiply through across the bottom. So I've got 1 times 60 seconds times 1. Well, that's just 60 seconds. And then I can do some reductions here. So 20 divided by 60 is the same thing as 1/3. So I'm left with pi over 3 radians per second. Pi is 3.14159. You might as well round pi to 3. So really, this equals 1. Approximately. I mean, it's 1 point something, but since pi is 3.14, we can round pi to 3. So 10 RPMs, or 10 revolutions per minute, is pretty close to 1 radian per second. All right, that concludes video 2.